thank you all for coming to this evening's webinar. Tonight, we will be going through the pasture demonstration sites that we have at Barooga and Savernake. And we have John Bruce here with us this evening to talk a little bit about the demonstration site as well. So in a little while, I'll throw to John. We have Richard Hayes from the New South Wales DPI to talk about maximising lucerne performance and persistence, specifically looking at lucerne density and companion species as well. And we also have Susan Robertson from Charles Sturt University to talk about the modelling that we've had done to upscale and complement the demonstration sites. So this webinar forms part of the Creating Landscape Scale Change Through Drought-Resilient Pastures project. This project led by Holbrook Landcare Network and is funded by the Future Drought Fund from the Australian Government through the Southern New South Wales Hub. As part of this project, we're also many partners, you can see there, and as a team throughout the different systems groups, we're aiming to increase the use of perennial pasture species within farming landscapes to increase resilience in dry seasons. So in the Riverine Plains region, our two demonstration sites were at Savernake and Barooga. So at Savernake, Chantel and Christine Gorman hosted our species comparison site, which aims to demonstrate lucerne seeding rate and variety on pasture persistence and quality. And the grazing demonstration aims to showcase the benefit of rotational grazing lucerne to improve pasture persistence, pasture quality, and animal production. So at the Savernake's demonstration site, there's a 50-hectare paddock that was sown to a Sadi 7 Series 2 lucerne in May of last year, 2023, with 3 kilograms per hectare each of Montaro and Monty subclovers. And within the centre of that paddock, there were 2 strips of different treatments, and one being a heavier rate of the Sadi 7 Series 2, 9 kilograms per hectare, with the same clover rate. And then the second strip was a combination of the Sadi 7 Series 2 with the Sadi Grazer, which is more of a grazing tolerant lucerne with a lower crown, again with the same subclover. So measurements were taken including plant density, quality, species composition. So looking at this photo that was taken in September of last year, it's a nice lush lucerne pasture with some subclover, and the neutral detergent fibre between the lucerne and the clover was fairly similar. And as for the crude protein and metabolizable energy, correspondingly fairly similar between the two, a high quality pasture. As for the change in the lucerne quality over time, as expected, from September through to January and March, when the next quality assessments were taken, see the increase in fibre and also a corresponding decline in the crude protein and metabolizable energy. Between the treatments, it's all very similar as to be expected, but it's the same variety of lucerne in the farmer control and the heavier rate, but no difference really was seen between the grazer. So that was for just the lucerne quality, with the annual subclover being dormant over the January and March measurements. As for the plant density, so looking at the difference between September and March for the lucerne, only the lucerne being there in March, but then the subclover being there in September as well. As for the plant numbers, there was no real change seen, pleasingly, between the start and end of summer, which is a positive, and we're wanting to promote positive grazing of these pastures so that they do persist over multiple summers, and Richard will go into more of this later, but lucerne may decline in its density there. But between the treatments, we didn't notice one over time, but between the farmer control and the Sadi 7 Series 2 heavier sowing rate, we did see that slightly higher plant number. In terms of the botanical composition, we saw a fair bit of clover in September and lower composition of the lucerne, but over in March, when the subclover was dormant, of course, most of it was the lucerne there with a very small amount of weeds, and fairly similar across the treatments. And as for the biomass, the Savernake site was first grazed for a couple of weeks in January, and so it had a bit of time to regrow before the next measurements were taken in March, where that photo is taken. And so we can see there's an increase in the total biomass there, but it of course depended on the grazing that was different there and a completely different time of year. So I'll switch now to talking about the Barooga demonstration site, which was looking at rotationally grazing between 4 paddocks. So in the 2 10-hectare paddocks were sown to a lucerne L70 variety of 9 kilograms per hectare and arrowleaf clover 6 kilograms per hectare in the A3 West and A3 East paddocks, which you can see in the top of that satellite image. And to be a part of the rotational grazing demo, an existing lucerne stand that was sown in 2019 that is under a centre pivot, as you can see with a nice green satellite image there, and that was a part of the rotation. So this just gives a bit of context for what the A3 West and A3 East paddocks look like in September, when they were sort of still getting going as establishing pasture. And there was a bit of ryegrass as well in the darker parts you can see there. So John, I'll throw to you now to talk to how you use lucerne and these pastures within your farming systems to graze your sheep and to provide some context. Thanks, John.
Thanks, Soph. I suppose predominantly where the way we use it, and it's happening at the moment, is and that pivot that the photo of the pivot that you might have on here as well. So yeah, so the pivot there you've got. We use these paddocks as predominantly as lambing paddocks this time of year. So that we've actually split that paddock east-west as well with a hot wire, 2-strand electric fence, which we do use a lot. That Merino use joined aboard Leicester rams, so we're breeding a first cross lamb. First cross ewe lambs is sort of our target. But yeah, predominantly we use these smaller blocks for lambing down in. So at the moment, we've got that pivot's got, I think, 500 ewes on it, split into 4 even mobs, and then those other 2 A3 East and West have got about 70 to 80 head on them. And then there's also, to the left of that picture, there's also another paddock of lucerne that was sown at the same time as the A3 paddocks, and it's the same. So our main we do have L70 sort of what we've been growing for quite a while now. We just found it's probably one of the most hardiest and probably a bit cheaper seed cost as well. But yeah, so obviously we sort of set ourselves up for lambing, more so from a point of view so we don't have to trail feed. In the past we have trail fed a lot, and obviously that's season dependent as well. But this year we don't have to. We haven't been trail feeding, so we've been lucky. Those dry land paddocks we've sort of been keeping the head pretty low on them, and yeah, like it's the lucerne is slowly coming away. We've only had sort of 20. I think we've had 20 mil here in the last week, so it has actually picked up. But and then obviously we we try and wean reasonably early, sort of around that 12 to 14 weeks, and then we also, a bit of a side note, we do sell a lot of, probably 50% of our winter cereals are grazing cereals, both canola and wheat. So having the lucerne now, before it gets too cold, as everyone's sort of aware, once we get your first frost, your lucerne sort of disappears for the winter. But the last sort of 4 years, we've been quite fortunate because the autumns have been quite mild. So if we've been getting rain, we've still been getting good growth. So once we sort of mark lambs, we shift onto our grazing crops, and then we'll, the likes of this pivot will come in and we'll do a winter a gramoxone, Diaron mix, and then a couple 100 kilos of single super with 80 or 100 kilos of potash as well. We do cut hay off this paddock, pivot paddock as well, but depending on the season, we have cut quite a lot of hay in the last few years off dryland paddocks as well. So that's probably we've just found, look, we've been growing it for forever, I've been sort of farming myself for 20 years, and I've tried chicory, I've tried everything, and as far as sheep tucker, you can't really beat it. The dry land, as you've seen, we do like to put 8 or 10 kilos of arrowleaf clover in with it, just to bulk it up. And then if you get it sown, like we've already sown some lucerne this year, back before Easter, so we'll get a grazing out of that season dependent in August or September. So I don't sort of, when we did this, so sort of come to me, I sort of thought, well, I know it's the best sort of pasture. Sort of, so I suppose it's just whether it's proving to other people it is, and through the millennial drought, or even 1819, when it was quite dry, it's hardiness. You can probably, 1819 we moved into containment feeding, so that changed the landscape a lot with our pastures. It looked after the country a lot better. So it's probably not a great example, but back in the millennium drought, you were flogging country pretty hard, and if you managed to jag 10 or 15 mil, you would get a green pick off it if you could, keep the stock off it. So that stand there, it was sown in 2019, and you can see the top of that picture that actually drowned. It got drowned out in, it must have been 21, I suppose, and we actually patched that area out and re-sowed it, and it's amazing how well it's come back. That paddock was, the irrigator went up in 2019, and it was, I think we turned 4 or 5 paddocks into one, and now we've split it with a permanent fence north south. So, but yeah, we thought we'd give it a go, but as far as the re-sowing, and it's actually worked really well. I haven't done it in the past, but we just did it with multi-disc, and then we just direct drilled in it with the air seeder. So most of our lucerne we just sow with an air seeder on 10-inch spacings. We don't, unless our irrigated stuff, we probably work up and we'll sow it with a spreader, just because you're up around that 20-25 kilos of seed. But our dryland stuff, it's basically a burner stubble and just direct straight into it. Put some Treflan out and direct drill straight into it. So it's a pretty simple system, but it seems to work very well.
Very good. Thanks, John. It's provided some great context to the site. And so a few of the pasture quality measurements were taken. Interestingly, in October, there was some grass weeds in there that just, I thought, out of interest, it'd be cool to look at the quality of the grass compared to the arrowleaf clover and the lucerne. And so, not surprisingly, the grass weeds had a much higher fibre content and corresponding lower crude protein, but metabolizable energy was fairly similar between the lush green pastures in spring. Over time, the again in March was between both lucerne in the A3, also the newly sown dryland pasture, was higher than in than earlier for both pastures, and it was even higher in A3 compared to the A7, being in the irrigated section. So its quality was a little bit lower.
So if I just caveat there, we sprayed the broadleaf weeds out in that A3. Just sort of think we buttress and broadstrike, I think, and the season hadn't it was getting a bit dry, and we sort of flipped a coin on the grass coming in and cleaning the grasses up, just because I was a bit conscious I didn't want to sort of lose too much ground cover. Hindsight, we probably should have come in and cleaned it up, but yeah, it looked a bit ugly there for a little bit, but yeah, you can't tell now, but yeah, we'll just see once we get the lambing ewes off it. We'll see. We're sort of getting on top of barley grass, but barley grass can be a bit of a tricky, like it's sort of one that can run away pretty quick in lucerne stands if not careful. So.
And it's interesting with the feed is feed and grain feeds feed in spring, but how that impacts on the persistence of the lucerne be interesting. I think Richard will talk on that in terms of companion species as well. So I thought, yeah, thanks, JB. And as for the plant density, didn't see any real change between the start and end of the summer. Apart from A3 West, the counts were lower in March than when we were there in October. October in the previous year. Whether that is due to it being just a little bit more raised and drier. That stock had been in there and grazed fairly heavily before that March measurement, and obviously they're in their rest period, but whether that affected the counts, it shouldn't have, because we're looking at the crowns, but just interesting to see that little change, but still fairly good plant density counts for the A7 West, where that was sown in 2019. As for the botanical composition, again, where the Ara leaf was growing in October and was in this dormancy in March, but again, where we saw plant density was a little bit lower in the A3 West, there was a slightly higher weed area percentage there. But the paddocks are pretty variable, as you saw with the photos before. So whether it was where we were taking the measurements that caused that difference, maybe. As for the biomass, so in September, looking nice and green, there was those grasses there as well, as Jamie mentioned, and then it had been fairly heavily grazed before taking the measurements in March. So I suppose it's representative of the change with grazing, how the biomass changes. More of an interesting note rather than the measurement. We can also see how your rice is going, JV, either side from start to nearing finish of the edges. And so the total biomass measurements reflect what we could see with the post-grazing. And yeah, I thought maybe I'll just ask one more thing, JB, while we're there, in terms of how you've grazed that A3 paddocks, being almost 1 year old now. As I mentioned, you had some stock on there over the summer. Your different grazing management for that new paddock compared to the existing one?
It's sort of different soil types. It's quite light and sandy. It's sort of 3/4 of those two with you. Those two paddocks used to be one. So the eastern side against the rice that you can see there, it sort of runs in a red loam, but it's quite light and sandy. So we sort of wanted to keep ground cover. We didn't want to flog it too hard. I probably playing around with the drone myself. It seems you think it looks all right from the ground, but you get above and it can look bloody terrible at times. So Yeah, we obviously they're a fixed stocking right now, but we don't, and we probably should. We don't essentially do, feed estimates or work out how much feed we've got on the ground. It's something I've sort of never done. So, it's just a bit of a gut feel that, oh yeah, that's paddock sort of done. We'll move them on, sort of thing. So.
Yeah. Very good. All right. I'll thank you, JB. We'll pass on to Richard now. So if you'd like to.
Thanks, Sophie. Let's get my screen up. So just an apology in advance, because I live in a little backwater. There's about a 10-second delay in what I can see on my screen and what you can see. So I apologise for that, but hopefully this will make sense to you. There we go. All right. And you, Sophie, you can yell out if you can't hear me or I'm not making sense or anything like that. So thanks for inviting me. Sophie just asked me to talk a little bit more about, I guess, some of the basics of lucerne and lucerne dynamics. As JB sort of mentioned, I mean, lucerne is the king of fodder. It's a very difficult plant to beat when you've got the soils to grow it, and it's just such an important species. And so we've done a little bit of work. I mean, there's been an enormous amount of work done, and we've just added a little bit to it. But just understanding lucerne and understanding, firstly, what to expect from it, and then secondly, how to monitor it and how to know whether, the sward you've got is the best sward that you can have. So I'm going to show you a bit of data from some of our trials, and it gets to the basics of, lucerne density and how to manage density and what are the major drivers of density. And I'll also add that all of this research is in dryland lucerne. So I'm not presenting anything on irrigated lucerne. Okay. So I'm going to share some data from a few experiments that we've got. I love this map because I love the size of Sydney compared to Bogan Gate, for those of you who are lucky enough to have been to Bogan Gate. But anyway, so this is where our trial sites are. And we sort of had two networks. We had 3 sites up in the central west, which was Cowra, Bogan Gate and Condobolin on a sort of an east-west transect. So, wetter through to dry, more favourable through to harsher. And we did a similar thing in the Riverine from Urungilly and Wagga and up to Marul. So we were trying to, it's not just about understanding lucerne, but it's understanding lucerne in its interaction with the environment. So we tried to get a good cross-section of typical environments in the Riverine and Central West. So I'm going to talk about the Central West experiments first. So just very basically, so you know what I'm talking about. So we had 6 experiments at this site. So we had the 3 sites, and we had one experiment sown at each site in 2013, and then we repeated that experiment at each of the sites right next door in 2014. So 2 years by 3 sites. They were essentially cover cropping treatments. So this is where we were establishing lucerne under a cover crop. And our general design was we had 4 crops, so wheat, barley, canola and lupin, and 4 configurations. So we had the pure pasture, so no cover crop, the pure crop, so the impact of the pasture on the crop, and then we had 2 mixture treatments. So one was the crop pasture mix, and the other was the crop pasture 1-to-1. And 1-to-1 is where we separated species in alternate drill rows. Okay, so this work was all about understanding, how we can manage lucerne and manage competition by changing row configuration. All of our research was on 10-inch row spacing, and none of these trials had fertiliser put in the drill row at establishment. We broadcast it prior to it. So here's just a couple of photos. This is just the wheat cover crop treatment. So there's lucerne in underneath that. So that's wheat on 10-inch row spacings with lucerne and clover underneath it, compared to the wheat pasture 1-to-1. And of course, we've concentrated all the wheat in half as many drill rows, and you can see a big gap in between them. So that's more or less what we were doing. Okay, so just a few key findings around lucerne density from these experiments. So this is a very busy graph, and I'll walk you through the graph first, and then we can get into the results. So essentially what we're presenting here are the sites, the experiments that were sown in 2013, and we're looking at lucerne density and how that changes over time. So from the establishment year, year 1, through to when the experiment ended, which was year 4. Our legend simply has our 3 sites, so BGs, Bogan Gate, Doblin, and then Cowra. And then within each of those sites, we've got our pasture treatments, so either pasture sown alone or nil crop, or our mixtures where the crop and the pasture has been sown in mixed drill rows compared to where it's been sown in alternate drill rows. And just so you can read it, we've also got on some of these graphs this LSD bar. So just so you can understand that, so that bar is essentially the size of the error. So if the difference in height between the dots is greater than the height of that bar, then we can say that differences are significantly different. And of course, the thing that stands out in this graph is the Cowra site, perhaps not surprisingly, where all the red lines sort of certainly start higher, but particularly where we sowed lucerne in the absence of a cover crop, it stayed higher right through to the end and was significantly different to everything else at the end of the experiment. Still, everything declined. Lucerne density declined at all sites, regardless, and that's a pattern that we see quite often. And if you've ever grown lucerne, you know that happens. Okay, so same thing, looking at the data from the 2014 experiment. So this is where, the same experiment at the same site, just sown 1 year later. And of course, we don't go through to year 4 because the experiment started at different time but ended at the same time. So we've only got to year 3 in this experiment. And the big standout here is that same treatment at Cowra, where we had the nil crop, so no cover crop. We were able to maintain lucerne density. And so that was quite novel. It didn't decline at all. And just note this, that density stayed at about 55 plants per metre squared. So we'll come back to that in a little minute. All right. So it prompted the question, okay, so why could we maintain lucerne density at that site at Cowra, but we couldn't maintain the lucerne density at the other sites? And of course, Cowra is the heart of lucerne growing country. And if you ask anybody, well, what do you think the difference would be between Cowra and Condobolin? Well, they'll say, oh, well, Cowra is a higher rainfall environment. Of course, lucerne's going to survive better. So we plotted the rainfall. This is actually just summer rainfall of the 3 sites over the 3 summers, if you like. And look, as you can see there, obviously the rainfall is different, but there's not a huge difference in total rainfall over the summers between the sites. It'd be a game person to say that, yeah, look, rainfall is the difference. Rainfall explains the difference in lucerne density in the Cowra site compared to the other 2 sites. So what else could it be? So the other thing I did was, and of course, at each of the sites in those summers, we actually got pretty reasonable summer rain, so over 100 mils most of the years. So the other thing I did was I plotted temperature, and it's really temperature that sets Cowra apart from the other 2 sites. No, it wasn't a lot wetter, but certainly a lot cooler. And plotting temperature, I've just plotted cumulative day degrees. And so at around 2150 day degrees, the Cowra site is, you'd say half or 2/3 of the other sites, so substantially different. So that seems to be what the difference is in lucerne survival there. So then I went through and had a close look at final lucerne density. So this is actually pretty rare data because in order to get this, I had to go and dig up 8,500 plants from over 380 quadrats. So it's pretty valuable data because I can tell you why people don't do this very often. But nevertheless, when you dig them up, you know the actual density. Okay, so it's pretty valuable. So this is the final lucerne density at our 6 sites. Now, On our graph, I've just labelled them A, B, C, D, E, F because I didn't have the space to do anything different. But A and B graphs relate to our Bogan Gate sites, C and D to our Condobolin, and E and F to Cowra. Okay. So the first thing we notice is at each of the sites, the final lucerne density was lower in the 2013 sown experiments compared to 2014. So there's probably two reasons for that. One was, well, the 2013 sown experiments were a year older, so the lucerne plants were a year older, more chance of dying. And the other thing is, of course, that first summer, the 2013 summer, was a little bit hotter and a little bit harder than the summers that followed. So there's probably those two factors that explain that, and that's probably a pretty unsurprising result. The other thing that you can see is just looking at the cover crop treatments, there wasn't a lot of difference across the sites in lucerne density, final lucerne density between treatments. So it didn't matter whether you sowed the crop in the same drill row or separated from it. More or less, lucerne density stayed pretty similar. But of course, pretty consistently at almost every site, there was a substantial increase in final lucerne density where we sowed the lucerne without a cover crop, okay? And in fact, averaged across all of those sites, that difference was pretty close to 40%. So just a little summary of what we've learned out of those sites. So lucerne density almost always declines with time. We know that, but it doesn't always happen, except at that Cowra 2014 site, okay, when conditions just happen to be okay for it. The presence of a cover crop in year one decreased final lucerne density by about 40%, as I just said. There was no advantage to lucerne persistence of separating from the crop on the 10-inch row spacings. So it didn't matter if we put them in alternate rows or in mixed rows, had the same effect on lucerne density. And we were able to maintain lucerne density in summers with 100 millimetres of rainfall and less than 2150 day degrees. So that kind of gave us a little bit of a benchmark. And not that you can do much about your temperature, but you know your environment and you know what you can probably expect in your environment. And you know that if you live at Condobolin, you're almost never going to get a summer like that. But if you live at Cowra, you will jag it from time to time. But it won't happen all the time, and you can't always predict when it happens. Okay, just moving on to the Riverina experiments. So these were a similar group of experiments in as much as we were looking at this changing row configuration, but we had some different treatments. We had the 3 sites, but we didn't repeat them like we did in the Central West. So we've only had 3 experiments. We had 10 treatments all up, and there were various combinations of lucerne and phalaris and subclover in different row arrangements. So in the top photo there, you can see lucerne and phalaris in alternate rows. In the bottom photo, you can see lucerne and subclover in alternate rows. These experiments were all sown in autumn 2012, and they were again on the 10-inch row spacing and no fertiliser in the drill row. We also had some extreme examples in these treatments. So not only did we have the alternate row, but we had some treatments where we had, 1 row of one species and 2 rows of another. So in this particular example, we've got 1 row of lucerne and 2 rows of subclover. And what that means is when we did our sowing, we had a standard sowing rate. So it just depended on whether we spread that same seed between 1 row, 2 rows, or 3 rows. So here we've essentially concentrated the lucerne seed into a third of the number of rows as the other treatment. So it's a little bit of an extreme example. Okay, so just looking at the lucerne density, a little bit like we did at the other sites. So here we've got our 3 sites, Urungilli, Marul and Wagga. And we're just looking at the site effect here. So 2012 was the year that we sowed it. So this was the initial lucerne density. And then 2014 was the final year. So only 3 years later. And then just looking at the change in lucerne density from the start to the finish. Okay. Again, LSDs. So that's our error bar. So if the difference in the height of the bar is greater than the height of that LSD bar, then differences are statistically significant. Okay. And what you can see from this site is that the main difference in lucerne density was at the Urungilli site. Lucerne density started higher, but definitely finished higher compared to a Marul or a Wagga. Okay, so looking at the climatic conditions again for the Riverina, we plotted rainfall, and we did get a summer with 100 mils at a couple of sites, but it was much drier down here. Okay, we didn't have anything like 100 mils in either year at Marul, and then only 1 year at Wagga and Urungilly. So rainfall wasn't nearly as favourable as at our other sites. But again, when you look at particularly Urungilly and Wagga, summer rainfall doesn't explain the difference in lucerne density that we saw. But if we plot temperature, just like we plotted in the other sites, again, Urungilly much cooler, much lower cumulative day degrees than either Marul or Wagga. 2150 was the mark that we hit at Cowra, so Urungilly a little bit warmer than that, but nevertheless substantially cooler than the other two sites. So that's interesting. Okay, so that was the site effect. If we move on to the row configuration effects, so this is where we've got all of our treatments. So this is the average of, in our row configuration plots, this is the average of our 3 sites. Okay, so we've got our lucerne-only treatment. So this is where we didn't have anything other than lucerne. Then we have lucerne and subclover in alternate rows. We had that one in the photo where we had 1 row of lucerne and 2 rows of subclover, and then we had lucerne and subclover in mixed rows. And then we did similar with the phalaris and lucerne 1-to-1, 1 row of phalaris, 2 rows of lucerne, or phalaris lucerne mixed. Okay, and again, we're looking at initial lucerne density in 2012 compared to final density in 2014. First thing you notice is that anywhere we had lucerne, anywhere we had phalaris, lucerne density, initial lucerne density was lower, and that's explained because our sowing rates were halved. Wherever we put the 2 perennial plants together, lucerne and phalaris, we halved the sowing rate of both, so we had a similar density of perennial species, and so that explains the difference there. The other difference that's probably more interesting is that our extreme treatment, our lucerne, where we had our lucerne in 1 row compared to 2 rows of subclover, after only 2 years, the density declined to half what it was at the start of the experiment. So this is quite interesting. And that was about 30 plants per metre squared. Just note again, our initial densities up here were around the 55 plants per metre squared. I'll come back to that in a second. So similar to the Central West experiments. Okay, so just looking at lucerne density, just looking at the plots with that lucerne density, how did they look? So when we sowed the lucerne in every drill row, that equated to 14 plants per metre of drill row. So for per linear metre within a drill row, we had 14 plants on average. Okay. When we moved to the alternate row arrangement, so we essentially halved the number of drill rows sown to lucerne, essentially that gave us 28 plants per metre of drill row. And then in our extreme treatment, where we had 2 rows of subclover and we constrained lucerne to only a third of the drill rows, that came to about 37 plants per metre of drill row. Now that's important because, well, we know, based on the data that we've got and our final lucerne densities, we know that density, 37 plants per metre of drill row, was not sustainable. So a sweet spot was somewhere between 28 and 37 plants. And I argue that it was probably closer to 28 because even at 28, we could start to see the diameter of the taproots reducing. Okay, so they'd be much more vulnerable to stress. So we're assuming that the 28 plants per metre of drill row under these dryland conditions and in these environments was probably about the maximum that we could sustain. So what are the implications? So what we found really was it was possible to maintain lucerne stands with greater than 50 plants per metre squared in these dryland conditions, but it was unlikely, particularly in the hot summer environments. Okay, if you're at Condobolin, you wouldn't expect to reliably maintain that density of lucerne. And therefore, if we don't expect to maintain it, we probably shouldn't aim to establish more than about 50 plants, 50 or 60 plants. We calculated that our establishment densities, if we assumed that 28 plants per metre of row was about our maximum target of what we could sustain, that equates, and assuming the strike rates that we got in our experiment, that equates to about 6 kilograms a hectare of bare seed for dryland lucerne. So if you're in a dryland condition, our experience probably is that it's probably a waste to go much higher than that. And then it's up to you to decide, well, you know, is 50 your maximum, or are you sort of back at 40 or 30, and you might adjust your sowing rate accordingly. But that gives you a little bit of a guide. And I think these benchmarks will be helpful just for growers such as JB to sort of monitor and think about, well, what is he able to achieve year after year, noting that every year is different. And of course, the row configuration will not help increase lucerne density. Okay, so the implications, we know that lucerne productivity is correlated with density. Lucerne can compensate, but there's still a decline as density declines. We know that cover crops reduce lucerne density by about 40%, and that's due to competition for light in year one. But otherwise, other than that, once we get it established, density, the decline in density is really driven by summer conditions, and in particular, temperature. The phalaris and the subclover in our experiments had little effect on lucerne density, and that's probably because they're not very active over summer. So our suggestion is, you know, given all of this, given that there's a maximum number of plants that we can sustain in dryland lucerne, there's no point, you know, sowing extra. Therefore, if we want to concentrate on productivity of lucerne and increasing that productivity, it seems to be more likely to achieve that by tweaking companion species than by trying to increase the density of lucerne. Okay. So, and of course, and I'm going to talk about companion species just in the last couple of slides, but there's other things that we know are important. We know that ground cover is important, and it becomes more important in drier sites. And we know that it becomes a problem where we've got lucerne grown by itself. Okay, so Marula at our dry site, you know, we were at barely 50% of ground cover, and I'll show you a photo of that in a second. And it was worse where we didn't have anything else growing with lucerne, either phalaris or one of the legumes. So this is our Marula site, and this is typical. You know, sort of midsummer, you end up with lucerne and bare ground, and it can be quite difficult to manage. And what that reflects actually is lost opportunity, because there's a lot of resource in between those plants that's not being captured. When you've got bare ground like that, well, obviously there's a lot of light in between that's not being captured. Not that that's going to be a problem at this time of the year. But the other thing is, when you've got bare ground, a lot of water will hit that ground and then evaporate straight away. So you're losing a lot of water as well. And some of our data sort of showed that. I'm not going to present that now. So it brings me to the question of ideal companion species. And of course, that's a very difficult question to answer, you know, without knowing the environment and acknowledging that people on this call are probably farming in very different environments. So just at a very general level, when we think about, you know, what is an ideal companion species for lucerne, we can consider the summer growing species. So things like chicory, or even things like tropical grasses. But I guess the problem with the summer growing species is that they're competing with lucerne at the most challenging time of the year. So we demonstrated in our own data that lucerne itself struggles to persist over summer. And if you get a very hard summer, lucerne itself will decline. Throwing another summer active species with it can be problematic in a lot of environments, particularly in the drier environments. And of course, you don't have that many robust summer growing species to choose from anyway. Perennial species as a group are a possibility, and things like strawberry clover possibly have a role in some environments. But the problem with perennial species is that they need to survive year round. Okay, so that means they're going to get no break from lucerne, which itself is a very fierce competitor. Okay, so in some environments, it certainly can be done, and we've got data where we successfully grew phalaris and lucerne together, for example. But that can be problematic, and you need to be fairly specific, I think, in the environments where you attempt that. And you also need to be conscious of managing the species as well. You know, putting a tropical grass with lucerne, I think, could be problematic in terms of grazing management and that sort of thing. So you need to be fairly specific. So I think probably where greatest opportunity lies, you know, in a general sense, is the self-regenerating annual legumes. And the benefit that these guys have got is that they avoid the summer drought. Okay, they're existing there, they're there in the soil, but they're there as seed. They don't need resources at that time of the year. They can just sit there. And then, as we've shown here at Marul, and this is by Cerula, when conditions become favourable again, the seed germinates and off it shoots. Well, that's certainly the idea. I think that's where we're going to have most prospect with companion species for lucerne, particularly in drier environments. But of course, it's still problematic. And as you can see in this Cerula stand, there's still plenty of gaps. I think we've still got to work hard to get the most out of a lucerne annual legume mixture. So thinking about what annual legumes you might talk about, and I've just got a few examples here. Subclover is the obvious one. That was the one that's, you know, traditionally been used. Some of the positive aspects of subclover, there's certainly plenty of cultivars available. It's not hard to get seed. We know it's grazing tolerant. I mean, that is its claim to fame, and we've grown it for years. It's well known and well understood. The problems with subclover as a companion with lucerne is a combination of two things. Subclover itself as a species has lower levels of hard seed, so it's more vulnerable to false breaks, and of course false breaks are more common when you've got a fierce competitor like lucerne growing next door. And the other thing about subclover is it's got a larger seed size. So when you get a tight spring, water runs out in spring, the clover's trying to set seed. It doesn't set as many seeds because they're big. It's got to put a lot more resources into a big seed than it would a small seed. So you tend, in a dry spring, you tend to get less seed set. And of course, most years are a dry spring when you've got lucerne growing next door. If you are growing subclover, and there's good reasons to do it, and people will still do it, but in drier environments, cultivar Izmir is probably the go-to just because it has got higher levels of hard seed than any other subclover variety. JB mentioned arrowleaf clover. It's a very popular one, certainly very easy to get seed of, and as he mentioned, seed's very cheap. It's got an advantage, it's very small seeded, so, you know, that's quite good for setting seed in a tight spring. It does also have some hard seed, although we're still trying to understand the hard seed, the hard seed characteristics of this species. The problem or the criticism that a lot of people have of arrowleaf, it does have a low level of winter productivity, and that can be problematic in some systems. And it does best. It likes to have late spring rainfall. You know, it'll punch on in an environment like Cowra. It'll punch on through to January if the rain keeps coming. And of course, if you're growing it alongside lucerne, well, things dry out very quickly, and so you don't always get the long spring. The other thing with arrowleaf clover is you often get variable seedling regeneration. So it's good in the year that you put it there, but it's pretty variable after that. Cerula is one that people talk a lot about. The good thing about Cerula, it's got very high levels of hard seed, and it's also very small seeded, so it's quite well adapted to these drier environments. Some of the problems with Cerula is it can cause photosensitivity in sheep, and so that also raises a question about grazing management with lucerne. So I can see an opportunity, particularly in large paddocks where you don't have controlled grazing, a great opportunity to graze the lucerne out, because the sheep will probably walk around and try and find everything else other than the Cerula first, and that will be lucerne. So there is potential for that. The other thing is not so much a negative, but certainly something that you want to be wary of if you haven't grown Cerula before, is that it's a different species and therefore it requires novel inoculum at sowing. So in order to get it to fix nitrogen, you want to make sure when you sow it, you do a good job with inoculating it and inoculate it with the right group of rhizobia. There are a couple of cultivars available, and as I said, they're both suited to the low rainfall environments. And the last one I'm going to mention is yellow ceradella. We're doing a bit of work with this at the moment. It's got a lot going for it, actually, the ceradella. There's plenty of cultivars available. It's also small-seeded, though not as small-seeded as Barooga. Most cultivars have high levels of hard seed, so not as vulnerable as subclover to false breaks. And it's a non-bloating legume. So people see that as a bit of an advantage, and I can see the advantage of putting that with something like a lucerne, which can cause animal health problems at different times. It also requires novel inoculum at sowing, but the inoculum you use for ceradella is the same as what you would use for lupin. The cultivars that you might try and look for are things like, if you're in a lower rainfall environment, things like Santorini or King. You may not be able to get seed of King, and perhaps there's others as well. So my last slide, look, in an ideal world, I'm just sort of thinking in general about, how we can get the most out of lucerne. My preference would be to see lucerne sown into a standing stubble, to start off with a bit of ground cover, a bit of mulch, because the ground will get bare soon enough. We want to sow on as narrow a row spacing as possible, and of course that gets harder if you're sowing into a standing stubble, but as narrow as possible is good, and it just comes down to what's practical and what you can achieve with the machinery you've got. I think we want to monitor our lucerne density. When we sow lucerne, it often looks good and we're impressed with it. What's the density of it? And I think that's a very easy thing to measure. It's a case of putting a little bit of mesh down and just counting the plants in a metre squared, and then see how close are you to 50 plants, and whether you think you can do better. And you try and calibrate it for your environment as to what you think you should target. And I think sowing with winter growing, small-seeded, hard-seeded companion legumes is probably the best bet for a companion species. And I'm certainly not recommending anything because, I know very little about your environment. If someone said to me, look, you've got a block of ground here at Barooga, and I'd like you to do a trial with companion legumes and lucerne, I reckon my number one pick would be yellow ceradella. And I think in order to get the most out of our annual legume, our companion legume, there may be some merit in establishing the legume the year before and getting a bit of a seed bank there. So you're not just sowing, 5 or 10 kilos of ceradella at the start. You sowed that last year and now you've got sort of 300 kilos of ceradella seed in the seed bank, because I think that's going to handle the competition from lucerne a lot better in the long run. But anyway, that's all I've got, Soph. So happy to take questions or talk about anything further.
Thank you. Does anyone have any questions before I'll switch to Susan? Okay, I think I'll pass right over to you, Susan.
All right, thanks, Soph. Yeah, thank you for asking me to talk today. So I'm just going to go through some of the modelling that I did, simulation modelling that I did for this project. So if you go to the next slide, please, Soph. So the modelling was aimed to be upscaling the two demonstration sites, so one practice site and one species site. We have had to modify that a little because of what limitations the model has. So the two questions that we looked at was, does rotational grazing of lucerne compared with set stocking increase pasture utilisation, sheep production and resilience to drought? And the species comparison was, does increased perenniality, so use of lucerne, increase production profit resilience to drought compared with an annual ryegrass pasture? Because that's something that apparently people in your region have, in between crop phases. Next slide, please. So what did we do? So we used the grass grow simulation model. So that's a very well-known model for grazing systems. It doesn't have cropping in it, so it's limited to only grazing systems. And I modelled between 1970 and 2019 so that we could get a few drought years in there for comparison. I used Finley because that was the closest site to the demonstration sites for which I had the rainfall data. And because this simulation was supposed to be representative of, what is commonly used in the sort of region, we used a first cross ewe joined to a Dorset ram. And I did two comparisons. So I joined ewes either on the 1st of November and sold lambs on the 1st of October. And I also joined ewes on the 25th of January to sell those lambs on the 23rd of October. Now, the management of the systems was that if ground cover fell below 70%, so target level, we took them off the pastures and put them in confined feeding until such time as there was sufficient pasture availability. Now, I did complete gross margins for these simulations, and I used fixed costs and prices out of the New South Wales DPI sheep gross margin budgets, which you could find on the website. So those are from 2022, so their average prices of 22, and just to get a bit of a rough benchmark, lamb prices at that time were about 780 cents per kilo carcass weight, and wool of this type, so a first cross ewe, about 400 cents a kilo. I did include a price grid for meat with a winter premium on price, roughly 10%, because that's reality. So what I modelled was a 4-paddock system, and I modelled lucerne with a strict 6-week grazing rotation. So they graze the paddock for 6 weeks and then they move to the next paddock, or in comparison, a set stocked system where they grazed all the paddocks at the same time, basically. Now, I did include pasture maintenance cost of $73 a hectare, and that was taken again off the New South Wales DPI gross margin budget. So if you disagree with that cost, you can alter the gross margins by or to whatever variation you wanted. So next slide, please. So for the first question, rotational grazing or set stocked, this first graph here shows you the monthly average pasture growth rates for a poor season. So this was the worst 10% of years, an average season, or a good season. So good being the best 10% of years, over that 1970 to 2019 time period. So what you can see there, if you look at that black line, those are the average pasture growth rate in an average type of year. So there's a bit of growth outside, over the summer, autumn sort of period, whereas in the poor year, the red line below it, there's very little growth at any time of year, really, and certainly not over the summer, autumn period. But if you look at the green line, which is the good year, lucerne, as we know, has, the potential for exceptional growth, outside the normal growing season, and that summer sort of growth is really valuable for a sheep enterprise. So if you look at the solid lines for set stocking and the dotted lines are for rotational grazing, and you can see there was not a great deal of difference between them. Yeah, so there just wasn't a great deal of difference in terms of the pasture growth rates. So we can go to the next slide, please. So the point about this, or one of the points about this simulation is that it's a model. It's a simulation model. It's not necessarily reality. And we know very well that rest periods are absolutely critical for lucerne to persist, particularly when when it gets dry. So I can't model persistence in this simulation. So just be aware that this is not picking up on persistence. We are just picking up on sheep productivity from the two types of grazing management. So while I did a strict rotational grazing system, of course, that was what I was asked to do. There are other grazing management systems where you could create a rest period, and it would really probably be optimal to move them by a food on offer trigger, so how much pasture is left in the paddock, rather than on a set time basis, which, you know, can tend to stress the pasture a bit more. But anyway, with our fixed time rotational grazing compared to set stocking, so there was very little difference on pasture, on pasture utilisation. But rotational grazing did increase the supplementary feed required because they were sort of stuck in a paddock for longer when there was not necessarily feed there. It did increase the risk of low ground cover. And because feed or pasture became limiting at some times, it did reduce ewe condition score and therefore the production from the sheep enterprise. Interestingly, though, rotational grazing did increase the weaner growth rate from weaning to sale. So that was, late winter, spring during drought years. So that was a benefit. So if you remember, the other point that we looked at in this simulation was the time of joining. And so there was a November joining and a January joining. And the later joining reduced the risk of low ground cover, certainly reduced the risk of low pasture mass in autumn, as you might expect, if it increases the risk of ground cover, and certainly made a large reduction in the quantity of supplementary feeding that was required, because obviously they're going to be late pregnant and lambing close to when, pastures might actually be growing. So, there were some big differences due to time of joining there. Next slide, please. So this is a fairly complicated graph, but what I'm trying to show here is what the key factors were that were impacting on utilisation, sheep production, and the gross margins. So the key factor, as we might expect, was stocking rate. So if you look at the gross margin is on the far right-hand side of this graph. Oh, I can't point. No. Yes, I can. And so if you're looking at the gross margins, I have the mean gross margin and the median gross margin. So the median is often a better value to look at because it accounts for the variability, between drought and average and good sort of years better than just a straight mean. So if you look just at the November joining time, just for set stocking, I've got ewe number per hectare. So I modelled either 2 ewes per hectare or 3 ewes per hectare. And you can see there's a huge difference due to stocking rate. Okay. And that difference, okay, does vary between the type of grazing and the time of joining, but it's consistently, a higher stocking rate has increased gross margin. Obviously, there's going to be an optimal stocking rate. I haven't, done a range of stocking rates to find out what the optimum is. 3 ewes is what Sophie and her advisors suggested was typical of this region. And so that's why I've chosen these stocking rates. But certainly stocking rate is a good way to optimize your gross margin. The other thing that made quite a difference was the time of joining or lambing. Okay, so we've got November joining and January joining. So if we just look at the set stock system for November joining, we have, a markedly higher weight of lamb sold. That's all over 10 kilos difference. Okay, remembering that these January joining lambs were sold on the 23rd of October. And these November joinings were sold on the 1st of October. So there's only a 3-week or so difference between them, despite quite a few months difference in the actual joining date. So this difference in the sale weight of the lamb or the age at what the lamb was sold is a key reason why the November joined ewes had a higher gross margin than the January joined ewes. Okay. If you delayed the sale of these January joined ewes or the lambs, we might expect quite a different outcome. Okay. The other point that you should note is that these November joined ewes had a much higher requirement for supplementary feed than the January joined ewes. Okay, because they're lambing when there's less feed about, and they're lambing, in late pregnancy and throughout lambing when there's not as much feed as we might expect for a later lambing. Okay, so the weight of the lamb sold and how much supplement you have to feed them are key factors influencing these gross margins. Okay. Now, typically, we would tend to recommend that a later joining, so for a late autumn winter lambing, might be a more profitable exercise. But it really depends on what time of or what age you sell your lambs at. So what weight are they? As well as have you actually increased your stocking rate with the later lambing? The point of a later lambing is that you're getting a better match of pasture supply to demand, so that there is actually the opportunity, if you're using the same grazing pressure, to actually increase the stocking rate of the later lambing ewes. So if you looked at the November joined at 2 ewes per hectare, okay, gross margin of 240. And if you compared that to the January joined ewes and said, okay, maybe I could run 3 ewes per hectare, this is 232, so fairly close, but it's still less profitable. That again is driven because we sold the lambs on 23rd of October. So if we retained those lambs for a bit longer, got a bit more weight on them, there was only $10 per hectare difference in this, we could very likely have increased our gross margin by later lambing and had less risk of actually feeding large quantities of grain. Okay, so quite a complex interaction there you need to think about. I'm sure you probably have thought about it. Next slide, please. So for this first rotation versus set stocking simulation, the key messages were that one, absolutely rest periods are required despite these results. They are required for lucerne persistence. There was reductions in sheep production from the rotational grazing system that I used, but optimising or having flexibility in the length of those rotations will minimise those reductions in sheep production. Stocking rate is clearly a key driver of income, and we need to optimise those. Later joining will reduce supplementary feeding, but it will also reduce your lamb sale weight unless you retain lambs for longer. So it's a bit of a trade-off. In this simulation, I didn't, the ewes were just managed the same from year to year. But strategic sale of stock in dry seasons is likely to reduce the risk to pasture persistence and having low ground cover, and will also reduce the chance that you're going to have really high levels of supplementary feeding in particular years. Okay, so strategic sale of stock is a really important factor in managing dry seasons. And the other interesting thing that came out of this simulation was that the rotational grazing actually increased the weaner growth to sale in drought years. But for other types of years, non-drought years, it also increased for November joinings, but not for January joinings. So rotational grazing, you may get some advantage to growth and the sale weight of your lambs. Next slide, please. So the second simulation question that we were evaluating was whether a lucerne pasture would be more productive than a volunteer annual ryegrass pasture, which might occur if you don't sell pasture out between phases of cropping. So this graph has probably a few too many lines on it, but anyway, I'll step you through it. So again, this is the mean monthly pasture growth rates for either lucerne or volunteer pastures in poor years being red and orange, average type of seasons, so black or grey, and really good years, which are the green lines. Okay, so if we look at an average year to start with, we can clearly see that lucerne has a much higher growth rate than the volunteer ryegrass, except during winter when lucerne just doesn't really grow very well. And certainly, extends the growing season or when you've got feed supply for sheep, which is a really good thing. In drought years, there's or very low growth for both species. Remember, this was the lowest 10% of years on record. So, we don't expect too much. But certainly, particularly during the autumn, the lucerne was actually growing slightly more quickly than the volunteer pasture. But in your good years, okay, you may get an early germination of an annual grass, particularly if this had been barley grass, we might expect quite an early germination, and therefore much higher production, but certainly cannot compare to lucerne. Okay, lucerne is capable of very high growth rates, over summer, autumn, if it rains. Okay. Interestingly, though, you can still see that there's this depression in winter production for the lucerne pasture, because it's just not growing particularly well due to the cold. So understanding those growth patterns is important as to understanding what feed you have for your sheep system. Next slide, please. So the key message from this is that the perennial pasture, in this case lucerne, provided a lot more feed between January and April, and supported a much higher condition score of the ewes at the same stocking rate, while reducing supplementary feeding. So this graph is the condition score of ewes in an average year. Again, it's your November joined system. And I've got two different stocking rates, either 2 ewes per hectare or 3 ewes per hectare. So the lucerne, you can see the blue lines at 2 ewes and 3 ewes, substantially higher condition scores, about 1 condition score higher, at least, in around about the joining time, than for the volunteer ryegrass pasture. Okay, so that's going to either, one, allow higher production, or we could actually increase our stocking rate of our lucerne versus what we could have with our volunteer. Now, when I looked at the levels of feeding, supplementary feeding, the risk of ground cover, etc., for this volunteer pasture, 2 ewes per hectare was sort of overstocked on this. So, we wouldn't be increasing our lucerne, but we would probably want to reduce our stocking rate on this particular volunteer pasture in the scenario that I modelled. But what you can see here is that, regardless of what pasture type it is, we're going over late pregnancy into lambing through autumn. We're losing a lot of condition, and so the nutrition of the ewes, maintaining nutrition of the ewes at this particular time, is really important in terms of not letting condition fall too far, but also the welfare of those ewes to have them in good condition at lambing to maximise lamb survival. And then through winter, pasture grows, and through spring there should be ample pasture, regardless of pasture type, and the ewes regain condition, ready for joining again. But certainly there was a huge difference in condition score between the lucerne and the volunteer pasture. Next slide, please. So how did that end up when you look at the actual sheep production and the gross margins? So basically, if you've got the gross margins, again, this is the far right column. The volunteer pasture median gross margin, $64 per hectare, whereas your lucerne, $193 per hectare, using my assumptions. So threefold higher gross margin. That was driven by, in particular, the weight of lamb. So this is at the same stocking rate, remember. So the weight of the lamb sold, over 10 kilos per hectare, 10 kilos per lamb difference in sale weight. And also the huge difference in the level of supplementary feed to maintain the sheep on the volunteer pasture. Okay. So that was the key things that were driving that. But if you also look across to the lambs marked per ewe joined, you'll see that the lucerne pasture actually allowed about a 10% higher number of lambs marked, which is quite significant. And again, this was driven because the ewes on the lucerne were in better condition score at joining and at lambing. So yeah, so huge differences in productivity. Next slide, please. So again, because this project was really interested in looking at how pastures compare over, you know, in drought type of years compared to other years, I've made this table, which is basically showing you poor seasons, average seasons, and good seasons. Okay, so how does the system perform in each of those types of years? So if we look firstly at the gross margin, okay, so for lucerne, okay, we've made a small positive gross margin. It's not good, but you know, it's positive. Whereas our volunteer pasture, you know, a significantly negative gross margin in those sort of drought years. Okay, that's driven by partly lower income per hectare. Okay, because again, our sheep sale income is, you know, $100 per hectare lower, and that's driven by land production. Interestingly, there wasn't that much difference in the total expenses, but the volunteer pastures certainly had higher levels of maintenance and production supplement. So production supplement was when they were put in a confinement area, whereas maintenance feeding was when they were in the paddock. Okay, so you can add these two together. So much higher levels of supplement than the lucerne pasture, but the costs were the same because I've assumed that pasture costs for a volunteer pasture were zero, while for the lucerne pasture was $73 per hectare every year. So just remember that. So basically, the volunteer pastures in this scenario produced less meat, so that's lamb and castrated ewes. And you know, lucerne pasture was at least able to maintain a positive gross margin in those poor years. Okay, next slide, please. So the key messages from that simulation question was that certainly productive pastures certainly allow much higher production, stocking rates, and reduced feeding, which is certainly an advantage in terms of increasing profit over the longer term, but also in terms of being able to, you know, be financially viable through drought. And the second point was that pasture species with a longer growing season like lucerne certainly can reduce the need for supplementary feeding of sheep and support higher stocking rates and weight gain, and therefore greater income than you know, shorter season pastures. I think one thing to state about this this simulation is that, okay, I've used what is supposed to represent a fairly productive lucerne pasture, and my volunteer pasture in this example, you know, I had a fair seed bank in there, but volunteer pastures do vary widely. You know, there are some that are quite productive and some that are extremely unproductive. Okay, so you do need to have a little bit of a think about what you know, how productive are your volunteer pastures? Do you have any inputs into them at all? And sort of balance that against this, which is only sort of one scenario. Anyway, that's all I had to say.
Thank you, Susan. Does anyone have any questions for Susan? No. Okay. So thank you very much, John, Susan, and Richard, for providing that recap on best management of lucerne, highlighting the importance of getting lucerne density right for your region and matching that to appropriate companion species based on having supply of feed throughout the whole year. And to understand the different gross margins and all the different elements that goes into those under different circumstances of sheep and enterprises, but the value of having lucerne in there. So we would love your thoughts from this evening's webinar. So if everyone could please follow this QR code to a quick survey or using that link. Are there any other questions for John, Susan, Richard, or myself based on what we presented tonight? Very quiet bunch. I hope you've taken a lot out of it. And please be in touch with me if you have any more questions to do with our Pastures project. And I think without further ado, thank you all very much for coming, and we'll leave it there.